Hello students, let's go for the next problem. Find the complex Fourier transform of the function f of x equals to 1 for mod x less than or equals to a, 0 for mod x greater than a. Hence evaluate integration 0 to infinity sin x by x into dx. Okay. Here two parts of the question is there. In that question two parts are there. One is to find the Fourier transform for the given function. Okay. Next, finding the Fourier transform. Using that obtained Fourier transform, we need to evaluate this term. Okay, we will see this one later. First, let us find the Fourier transform of the given function. F of u. F of u is nothing but Fourier transform of the function. Here variable is u. F of u is equals to integration minus infinity to infinity. This, here they have told it's a complex Fourier transform. It is also called Fourier transform. It is also called infinite Fourier transform. All are same. Okay, why it is called complex? Complex, I told you already. There is a complex term in the definition. Therefore, it is also called complex Fourier transform. This is the definition of a Fourier transform. Now let us substitute the function f of x here. We need to substitute the function here. The function depends on the limits here. By data, here two functions are there. We need to consider any one of these one. This depends on the interval here. By data, f of x equals to 1. Why it is 1? For mod x less than or equals to a. Means what? The value x is defined in the interval minus a to a. Minus defined in the interval minus a to a. Therefore, we are taking the function as 1 for our Fourier transform. Minus here the limits are minus a to a, 1 into e to the power iux into dx. Okay, now we need to integrate this e to the power iux between the limits minus a to plus a. Integration 1 into e to the power iux is nothing but e to the power iux. Integration of e to the power iux is nothing but e to the power ax into dx. That is equals to e to the power ax upon a. Using that one, this becomes e to the power iux upon iu between the limits minus a to a. Minus a to a. Now substitute the limits. Here you can see 1 by iu is a constant term. Substituting upper limit a, that is e to the power iu a, means wherever x is there, substitute x equals to a and minus a. E to the power iu into minus a. Next, simplify this one. That is equals to 1 upon iu into bracket e to the power iu a minus e to the power minus iu a. 1 upon iu into bracket. Now you can see this complex number is there, exponential form. Applying this one definition for that. Cos ua plus I sin ua is already you know that. E to the power iux, e to the power ix is sin x, cos x plus I sin x. Like that only, cos ua plus I sin ua minus cos ua minus I sin ua. 1 upon iu into bracket cos ua plus I sin ua. Next, minus, multiply minus to the bracket terms, that is minus cos ua minus into minus plus I sin ua. Next, here cos ua minus cos ua here cancels. We left with I sin plus I sin ua plus I sin ua, that is equals to 2I sin u. 2I sin u. Next again here I cancels. We left with the answer 2 sine UA upon U. This is nothing but required Fourier transform for the given function. This is the required Fourier transform for the given function. This is one part of the solution. Next they are asking to evaluate. Evaluate means we need to find the value of the given term, that is integration 0 to infinity sin x by x. Sin x by x. Okay. To find that value, we need to consider the inverse Fourier transform. Now let us evaluate. Integration 0 to infinity sin x by x with respect to. So evaluate means we need to find the value of this term. Okay, to find this value, let us consider the inverse Fourier transform. Inverse Fourier transform is f of x equals to 1 upon 2 pi integration minus infinity to infinity f of u into e to the power minus iu x into dx. F of u into e to the power minus iu x into du. Here we are doing integration with respect to e to the power minus iu x into d. Here we have obtained f of u is equals to this. F of u is nothing but what? 2 sin ua upon u. 2 sin ua upon u. We obtain f of u, that is equals to 2 sin ua upon u, or this also we can write it as 2 sin au upon 2 sin au upon u. Now let us evaluate this one by considering inverse Fourier transform, that is f of x equals to 1 upon 2 pi. Now substituting f of u, that is 2 sin au upon u e to the power minus iu x into dx. E to the power minus iu x into dx. Next here 2 get cancels. Now we are not integrating here, we are just evaluating here just by substituting necessary conditions here. Now we left with 1 upon pi integration minus infinity to infinity sin au upon u e to the power minus iu x into dx. This is nothing but f of x. Now I am going to put x equals to 0. Putting x equals to 0, we have f of x is equals to 1 upon pi integration minus infinity to infinity sin au upon u e to the power minus iu into 0 into dx. That is equals to 1 upon pi integration minus infinity to infinity sin au upon u into 1 into dx. How it is 1? Because you can see here e to the power minus iu x, sorry, iu into 0 is equals to e to the power 0. The value of e to the power 0 is 1. Therefore I have written it as 1. This is nothing but 1 by pi integration minus infinity to infinity sin au upon u with respect to x, that is equals to, okay, here we are substituting x equals to 0 means we are substituting f of x equals to 0 means If you substitute x equals to 0, here we are going to get 1. The value of f of x, that is f of 0. Because you can see here f of x equals to 1. How it is 1? We have taken f of x equals to 1. There is no x term. You can't put x equals to 0. Therefore f of x here we have, it is 1. That is we have taken f of x equals to 1. That is equals to 1. 1 by pi integration minus infinity to infinity sin a u upon u into dx is equals to 1. Sorry, it is du, no? du, sorry. It's with respect to u. With respect to u it is into du is equals to 1. Next, we know that it's a basic property. Just reminding you, integration minus infinity to infinity f of x into dx. This we can write it as 2 into integration 0 to infinity f of x into dx. This is a basic property of integration. Basic property of integration. Using that basic property of integration, we can write it as, that is 1 by pi into 2 integration 0 to infinity sin au upon u with respect to u, that is equals to 1. Okay. Next, put a is equals to 1. Put a is equals to 1. Why we are substituting x equals to 0, a equals to 1? These all we are going to get the value of this term. Right? Now putting a is equals to 1, that is this is 2 by pi integration 0 to infinity sin u upon u with respect to u, that is equals to 1. Next, transfer this 2 by pi to LHS, we get integration 0 to infinity sin u upon u into du, that is equals to pi by 2. That is equals to pi by 2. Next, this is nothing but we have the function with a variable u, but they have asked the question with a variable x. Therefore, changing u to x. Here the variable is u, but the question asks is the variable x. Therefore, we are going to change the variable u to x. That is integration 0 to infinity sin x upon x into dx. That is equals to pi by 2. Pi by 2 is the answer for this term. Right? This is nothing but the given question. They are asking to evaluate this term. Evaluate means find the value of this term. Now we have obtained the value as pi by